Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
This is Carl Carlson, and this is Speaking of Reliability.
Thanks, Carl. And this is Fred Shankberg.
Yeah, I got an interesting question from a listener, and I won't go over the company and that kind of thing. I'll just talk about it generally, but it was a fascinating question. It opens up all kinds of discussion topics. So this is a person who had read my book, and he wanted to ask about the assumptions that go into a Design FMEA and they have, I'll just say it's a widget, but it's a particular type of product.
Mm-hmm.
And he was asking things like, if the product actually meets its dimensions, do we assume it's going to work as intended? And then he asked a question, well, what other assumptions should we make and things like that? So I just thought it'd be fun to talk about what assumptions go into a Design FMEA, and then I'll refer this person to the podcast as well as the answer that I already gave him.
Yeah, it's one of those cool features of when we get questions like this, you and I and the other hosts provide an answer usually within a day or so and try to either get more understanding of what the question is or provide our thoughts on it if the question is relatively clear for us. And we also then make it fodder for a podcast. And I have found every single time we've talked about a question, I have to go back to the person posing the question and say, oh, there's more info in this podcast. Like, here's a few things I learned during that. So I think you get an answer right off, and then you get a better answer when we get a chance to chat through it.
That's the amazing thing about a podcast session, which is true in teams, is I often learn things in the podcast. Actually, the back and forth goes, oh yeah, I hadn't thought of that.
Mm-hmm.
And it sort of opens up some nice interactivity that I think can be instructive as well.
Well, that's one assumption I make about our conversations. We're going to learn something and have fun.
Yeah.
On FMEAs, it just kind of blows me away with the number of assumptions we make, and many of them are not stated, which I think is dangerous. And the idea with this person's asking, saying, if it's in tolerance, will it work? Well,
maybe not.
Maybe not. And engineers, I mean, if it's a complex design of any sort, and you got like 8 steps where these two things need to align or do something like that, that's a difficult engineering problem to meet and to be able to assemble it in any industry. And getting them all in tolerances that don't destroy yields of manufacturing, and it still works, that's engineering talent at work to make those things happen. And I asked a question just a couple of weeks ago of a mechanical engineer. Says, how do you go about tolerancing? Like, make them as tight as possible all the time.
Oh no.
Okay, we got to talk about this.
Yes.
So tolerancing in and of itself is a whole discussion in and of itself. Yeah, but it's one of those that it's worth saying in the Design FMEA, because it opens up the amount of variability in the process and how well we're understanding it in the design. So are we assuming that tolerances, if an item is in tolerance, will it work? That may open up all kinds of other risks that the mechanical engineers, electrical engineers, and others are just saying, wait a second, we're not that rigorous on doing this. We're doing a carte blanche 10% across the board. We don't know if it'll work or not work on that. And then you can add it into the Design FMEA. Maybe we do need to pay more attention to the critical to quality type aspects and which tolerances are important versus not, and so on, and get good information there. Whereas if you just assume they're good, it's off the table and you're not going to bring it into the risk assessment.
Right. So let's start with some principles on it. Like if a person is doing a Design FMEA, typically you want to assume the product is manufactured according to specification. You're not, because you're not looking at the deficiencies in the manufacturing process in a design FMEA.
I bring that
There are
in.
exceptions to that.
Yeah, I bring that in when it's a critical or safety issue.
Mhm.
And one of the risks in the design is that we're probably not able to take into account all the variability in manufacturing or from a supplier or whatever.
Right.
And the risk might only be scrap if we have a way to catch it, or it might be performance or safety issues when it gets to the field. So I bring those into the design FMEA. We need to
Yeah,
design
exactly.
those for those.
And that's the thing. And you go to a DFMEA class, and the instructor will often say, well, in a DFMEA, you assume the product is manufactured appropriately. There are exceptions to that that are really, really important. And I'll just share a story here, going back to General Motors days. One of the early FMEAs that I supervised, I was the manager of the product reliability there, and they were doing this back in the late 80s, early 90s. They were reevaluating their doors because we were getting um, the Asian automotive companies had doors that fit beautifully, and the domestic automotive companies didn't fit as nicely.
Didn't you told the story with this guy who had a 2x4 and was
Yeah.
bending the
So,
hinges to get him to align?
so now this will be a similar to that story, because that's part of the story, is the adjustment in the manufacturing floor that actually adjusts the door. And the point is, do we need that or not? Can we make the design good enough so you don't need to do those extra adjustments?
Right.
And that became like one of the engineers that when we were doing this FMEA said, do we assume that they're going to continue doing that adjustment, that they'll need it? Or can we design this product that, in other words, it's a failure if when you turn the bolts on the hinges, it doesn't line up?
Right.
And I thought, well, that's an interesting question. Maybe we should, because that's the way it was being done in the Asian companies. The plants would just go zip, zip, and the thing fit. And they didn't have to do these door adjustments.
Yeah. And there's all kinds of, design features that will make the adjustment dynamically, because the
Yeah.
frame is not going to be solid structural. It's going to move, it's going to bend, and you're going to have
Mm-hmm.
plenty of shock and twist and everything else going on with it. Yet if you design a door that within some range finishes its closure by aligning itself, that would be another idea.
Yeah. Well, you're right. And so these are all the things. This is why I'm very careful about making this assumption when you're doing a design FMEA that it's going to be manufactured and assembled according to specifications. I want to consider what's called design for manufacturability and design for assembly. Those are very much design topics.
Yep.
Those are actually functions in a design FMEA. And therefore, I don't want to always assume
Yeah.
what is typically assumed. And so this is a really interesting topic that the person brought to attention by asking the questions.
And it's a good question, is because there's one motivation is if I can simplify and focus the study by just making these assumptions and not consider those whole fields of things that could be risks for our design, then it focuses on to the design functionality and these other aspects of it. Yet I agree with you is that I would make those assumptions explicit. It's saying, all right, we do that when we set the scope, right? We say, we're going to talk about the door, the hinges, the mounting of the hinges, and not the structure it's mounted to. We're going to assume that that's fixed versus saying, we're going to assume we're not going to make that assumption. Our scope is now going to be the entire frame as it affects the location of the where we're attaching the hinges. So we're making a lot of assumptions when we scope something out. And I think you and I and other good facilitators say, all right, this is in and this is out. We're going to do the cable,
Yeah.
the connection, but not the wall socket.
Exactly, Fred.
Kind of thing.
And those need to be documented openly, like with the team. Uh, there's other assumptions that go into this. Like, for instance, do you assume that the user is going to use the product according to specifications, or are there times when they're not? And
Well,
this gets
that's
into things like the uh, the cell phone. What if the cell phone gets dropped?
yeah,
From
yeah.
what height? This gets things about, you got a four-wheel drive truck. Well, okay, so you're going off road. What if you keep the four-wheel drive going while you're going down the highway? Da da da
Hmm.
da. There's so many questions about if a customer uses a product outside the envelope. Do you assume they're never going to do that? How about you want to make the product safe, even if they misuse it
Yeah.
in some way? These are so important to bring up at the beginning of an FMEA.
And it sets kind of the boundaries and so on, yet it's a trade-off. You still want a good set of brainstorming. What could go wrong? And if you say we're going to assume they're going to use it correctly, you miss you're very likely going to miss some critical things.
Yeah,
So, but let's assume that we're not designing this to survive a meteor strike or a direct lightning strike. Okay.
yeah,
Let's
that's
just
okay.
assume that, all right? And it
Hmm.
sets a quasi boundary. Is like there's some things that we just can't deal with, yet if somebody is driving during a lightning storm, are they safe inside the vehicle? Right?
Right,
That's going to
right.
happen.
Yeah. So the what if brainstorming is really an essential part of the of an FMEA. You want to be sure you're not missing something that could happen, and you want your product to be safe. Let me answer the person's question that I posed right at the beginning as clearly as I can. He's talking about if the widget is dimensioned to be such and such specification, and does the FMEA, DFMEA assume that if it makes that the product will perform as intended? And I'm going to say no. We don't want to make that assumption because one of the purposes of the DFMEA is to make sure that you're discovering potential design deficiencies
Yeah,
that, and even if you're within specification, that design might not work.
yeah.
And that's what you want to surface in a DFMEA.
And there's plenty of ways you're going to find out. But if you are designing without any prototypes, well, are we doing simulation to see
Mhm.
the variation effects on what this is and will it still work? Or circuit analysis and looking at variation of our, 100 puff capacitor is not always 100 picofarads. What if it's not? And we can deal with things like that. Yet, if you don't ask the question, and we just design, I had one designer tell me is we design for success, and you're always in here telling us how it's going to fail.
Yeah.
Like, yeah,
Hmm.
well,
Right.
that's great. Plan for success, be prepared for failure, because it's going
Exactly.
to happen. But yeah, I'd keep more in than not in general, and make assumptions as far out as you can or as minimal as you can. Yet I agree though that there's a trade-off. We don't want to cover everything in every scenario. And if we have a plan that, for example, on the tolerancing for this widget, if that team knows that they have a solid tolerancing program and they have great information about the variability of stuff, they're probably thinking through this tolerance is set so that it will work at these levels. If that's
Hmm.
not part of that mindset and it comes out in the DFMEA, now we can go address it. Whereas if we blanket make the assumption that anything in tolerance is going to work, it doesn't give us that chance to reflect it. And the occurrence rate will go way down if the team really thinks they have a solid program. If they're not sure, that occurrence rate may go up. That, yeah, it's like some of these tolerances are probably not going to work.
Well,
If
in fact, let me expand on that to a little different aspect of it. If you're doing a process FMEA, so imagine you're doing the widget manufacturing process,
Mhm.
and I've been asked in such sessions, uh, where I've been actually told, we just need to assume that the supplier parts are good. And I go, wait a minute. You go, well, we don't have any control over the supplier parts, so we're just going to assume no. You actually have an incoming uh, station, and they go, well, they warrant the parts are good. Yeah, but what if they aren't? And so we had a long dialogue, and we ended up in that particular session deciding that in certain circumstances we have data that shows that this supplier parts are not necessarily good. We need to make sure we know what to do in the manufacturing process. We don't want to just assemble and ship if it's got a bad part in it.
I did pick up it was a summer in, I think it was in Washington, D.C. or Baltimore or something like that. And it was a beautiful day. And I got off the plane and picked up a rental car, and it was a convertible. I'm like, cool, score. I got a
Aren't you
neat
lucky?
little car. It's a good day. And I didn't move it even, I didn't even turn the thing on. I got in, put my luggage in, and the door wouldn't close. I had to lift it about an inch before it would latch.
Oh my God.
And no, I'm not dealing with this car. And I walked back and turned it in, and he goes, "You're the third person today wouldn't take that car." It's like, I am never going to buy that brand or that model. And the car only had 8 miles on it.
Wow.
Yeah.
Plays as
Oh my
is.
God. Yeah. What a deal. It's the idea is, yeah, we can make it up for it in manufacturing, or well, if you have a way to either it doesn't fit in manufacturing and you catch it in scrap rates or rework stuff, where those things all cost money. Yet doing incoming inspection for every tolerance is not likely to be cost effective at all. It goes back to that trust and verify, which is probably a whole different podcast. Yet blindly believing your supplier, and I think you and I have many, many stories where no, that's not a good idea.
Yes,
They
exactly.
have to prove it, you know. If you've
Hmm.
got a long history with this hinge comes in and it's in spec, it just works. We've never had issues with it, and the CPK value of their production of their tolerancing or their dimensions and everything else is, 8 sigma or some huge number. Don't worry about it, right? If you get a failure, do the root cause on it, figure out what's going on. And then if you see three of them on a Friday afternoon, well, you might want to redouble the checks and, increase the scrutiny of it. Yet you don't have time to check everything.
Right, exactly. And that's where that leads right into another topic, which could be, and certainly is another podcast,
Jeez, we've
which
got
is the
like four of
subject
them going now. We got four or five.
which is the subject of special characteristics.
Yeah.
If you know the vital few characteristics, both product and process, that make a product work, then it's very easy to know if your supplier parts because you can check those vital few special characteristics, but you have to know what they are.
Yeah. And part of that is that FMEA is if you're making too many assumptions, you're going to gloss over, well, what's if the variability of the supplied part is at the edge, and that first assumption in that question you got, Carl, is, well, can we assume it'll just work? And like, well, if you don't know, then no. If you
Yeah,
don't have the
exactly.
data, you don't know.
So one of the other questions the person asked, when conducting a DFMA, to assume the component drawings are not yet finalized. And that's a resounding yes. You do not want to assume that the drawings are finalized when you're doing a design FMEA.
Talk about limiting your options to resolve
Yeah,
problems.
that would, like, why are you doing it? In other
That's
words,
right.
you're doing an analysis of the design. If your design's frozen, then I think you're just too late doing
Well,
that.
there's sometimes you have to, and it's
Yeah, I
you come
realize.
back to an FMEA and you've locked down the design. There's no such thing as a locked design. At some point, this has got to be fixed, and we'll open it up and fix it. The
Yeah.
threshold for change changes, and that happens with every design process. Yet the idea is that now you're limited more so to mitigation issues and evaluation issues or process issues as opposed to design changes, where if you do it appropriately early in the design, then it's, as Chris Jackson often says it's free, easy, and cheap to make design changes when it's early.
Right, right. And so you want to, as you mentioned, Fred, you want to do the FMEAs early, DFMEAs early in the design process. So you're actually influencing the design well before the design's frozen. And you're also influencing the tests to make sure
Yep.
the tests actually discover the failure modes of concern. The last point he asked, what really brings up the same topic on process FMEAs. Here's a a rule, I'll put in quotes around the word rule, that in a process FMEA, you assume the design is sound. And yes, you can do that to look at your process, but you also have to ask the question, what if the design isn't sound?
Yep.
Is there something about the process that'll, first of all, you can influence, you can have the PFMEA team go back to the design team and say, you know what, if you just put in this little feature, it would never be misassembled.
Yeah,
And
it's
so
an
you can,
alignment feature, for example. Very easy to add to some
yeah.
designs and so great to avoid mistakes on the production line.
hmm So I mean, I got to say this right because it's not foolproof. We used to use the word foolproof, but people changed it to you basically want a robust design that can't be misassembled. And that's what you're looking for. If you don't have that, that's key input to the product design, even if you're sitting on the manufacturing line. So I'd be careful about these blanket assumptions that people make on whether, if you're doing a design FMEA, do you always assume the product is manufactured correctly? I'd say there are exceptions to that, and you
Yep.
need to know how to surface those, and vice versa.
Yep. Yeah. I don't know. Is the design FMEA and the process FMEA harken back to the days where the design was thrown over the wall?
Yeah, the you don't want to do that. I remember learning this from a colleague of ours, Deborah Hisha, for years ago.
Hmm.
And he would say, do them in parallel. You can have a design team, and the reason why they are separated is the design is looking for design deficiencies, and the manufacturing process FMA is looking for process deficiencies. So they have different objectives and different people, but you can have them occurring in the same similar time frame. And that way, the PFMEA team says, hey, you guys over on the design side, you need to be doing this, and vice versa. They can be communicating back and forth. Um, or some people have tried to put them all in one meeting, and that gets into the subject, which is outside the scope today, which is
That's
you have
number
a very
6
large meeting.
topics. A great question just leads to all these other topics for us.
Yeah, yeah. It's so much fun when you get good questions. So please, if you're a listener and you have any questions about any topic of reliability, FMEA, any tool of reliability, please get in touch with us. We have a great time, as you can tell, addressing questions, and we want to hear from you.
Yeah, and it's very true. It's surprising. After 1,100 episodes, there's no question too big or too small. We can, as you can already know, if you've listened to more than one episode, we love talking about this stuff. And it's even better when we know we got an audience that's asking questions and following us. That's great. And you can get questions to us over at accendoreliability.com/go/SOR. A couple of ways to post or pose a question to us there. And Carl and I and the other hosts are available through LinkedIn and our About pages. So many options for you. No assumptions about what your question is or so on. We'll try to get an answer back to you or direction or resources or whatever. And good number of them we sanitize a little bit and bring into a topic, and then we get even better answers back to you. So hopefully, and other people can learn from it too. So there's questions big and small. We enjoy them all. Oh, that even rhymed. That was not a, that
Very
was not
good.
a, my mom would say, you're a poet and you didn't know it.
Excellent. Well, can't top that one, Fred.
Hey. Well, thanks, Carl. I kept notes. We have like 5 more episodes of topics after this one discussion, so or 5
We
or 6.
do.
So yeah, so plenty
All
more
right.
coming. Thanks for the question, and thanks, Carl. We'll talk to you soon.
Talk to you soon, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.